So we need to determine an equation of an inverse of negative x squared plus 4, sketch the graphs of both of them, and then decide whether or not that inverse is a function or not. So algebraically, to find the equation, step 1, switch x and y. And then once you've switched x and y, we need to solve for y. So if I take this graph and I move the 4 over, if I want to get rid of that negative, then I can multiply both sides by negative. You could have also moved the y squared over and moved the x over. There's a number of different ways you could go about this. But now that I've got the y squared by itself, I can get rid of the squared by square rooting, remembering that plus or minus in front. And so there's the equation of the inverse. Sketch both graphs. So I am going to do the original graph in green. If we were using transformations, what is the parent graph? Just our x squared graph. What does that negative do? Flips it down, and then the plus 4? Is it up 4? Okay. So are we okay with that as our graph? An x squared flipped down, then moved up 4. If I would label some points on this graph, I know the vertex is at 0, 4. We've got 2, 0, negative 2, 0. We could label some other points as well if we wanted. I'm going to graph the inverse in black. Now you can either decide to use the equation or to use the graph. If you have the graph, often the graph is easier to use because all you have to do is switch the x and the y. So instead of 0, 4, you're going to have 4, 0. You're going to have 0, 2 and 0, negative 2. And there is the graph of the inverse. Is the inverse a function? No. Doesn't pass the vertical line test. Yes? Some. And we're going to figure out which ones, how you can tell from your original function right away whether your inverse is going to be a function or not. Now I want to look at this inverse equation because we graphed it from the points by switching the x and y. We didn't graph it from the equation. With this plus or minus, what it really means here is you have two different equations. The first equation is with the plus, so that would be negative x plus 4. The second equation would be with the minus, which would be minus negative x plus 4 in a square root. Do you recognize the parent graph? Square root of x. What's the negative going to do? Reflected across the y-axis, a horizontal reflection. What's the 4 going to do? Okay. Why did it get moved to the right 4? Because of the special note we wrote yesterday. And this is the hardest situation to see that special note. Whenever you have a horizontal reflection, stretch, or compression, which we do, and a horizontal translation, which we do, you have to write it in factored form. So before I can do the transformations of this one, I would have to, then minus is so hard to see because it's just tiny and it seems so innocent, but it's negative. Don't trust it. No, just kidding. So you have to factor out that negative, and then you can see that it is 4 to the right. And that's what matches up with this top part of the graph. And the second equation, you'd have to factor that one out as well. But the negative out in front would flip it down. The other negative would flip it across. And then it would still move 4 to the right. And that matches up with this bottom part. And this explains a little bit why, a square root is opposite of squaring. And their graphs match too, in that the square root graph is half of a parabola. Ray?
All three of them are exactly the same.
Okay, no. These two are the same, and this one would be the same with that one. And the top one represents the top part of our black graph, and the second ones represent the bottom part of our black graph. Yes?
How do we flip it to the bottom and the right, as you said?
For the second one,
Yeah.
so the negative outside the function would be a vertical reflection. That flips it over the x-axis. So I'm going to start, here's my standard square root graph, right? The first negative, what would it do with this? It would take it and flip it down. So now we have our graph here. The next negative inside would take this and flip it over. So then it would move over here. And then finally, move it 4 to the right, would end there, and that would be the bottom part of that black graph. Magic. I didn't want that one to disappear. See, it knew that all those things weren't the right answer. That's why it disappeared as it went. And now it knows that's where we're done, so it said, okay, we'll keep that one. Okay.
This is going to be there Monday.
No, it'll disappear. All right, questions 5 and 6.